confident are you at ensuring that you have picked enough load combinations for your given structure? How confident are you in using what the software produces as the default? Are you confident in trusting the software that it has considered all possible load combinations? Very often the answer is no to all of those questions. It's for this reason that I've developed this program called the Load Combination Generator, and it's catered for the Eurocode, but it's also can be made applicable to other various design codes out there as well, but predominantly it's just catered for the Eurocode. So the software starts by firstly importing all the modules that we need. So once all of the modules are loaded successfully, they'll let you know that, and I say you may proceed. So I suppose first off, on a global scale, it's important to know if we need to consider any national annex. So we can choose from none, Ireland or the UK. Now there is scope to obviously put in other national annexes, but for the time being it's just limited to these three options. Depending on what we select here and every other choice we make after this will either add more or less functionality to the load combinations that's generated. So for example, if we choose the Irish national annex, that will influence the type of psi factors that are developed for the rest of this program. Likewise, if we just stay with the default, that'll also influence different factors for the rest of this program. So we'll just start off with picking Ireland. Next we pick the type of structure and the design life. So as you can see here, the national annex is set to Ireland, which we've picked here, and it allows us to pick an indicative design working life in years. So it gives us examples here as well, which is taken from the Eurocode. So you will notice that we have a range of between 10 and 30. Now if I change that to none and I rerun it, you'll see that that's changed from 10 to 25. So like I said, everything that we pick is based off the options we have selected previously, and obviously you can go back and forth as you see fit. So say for example we are going to design building structures and other common structures, so that's telling us we have a design working life of 50 years. Okay, so we pick that, say the design working life. So a design working life of 50 years has been stipulated because it doesn't give us any space to pick an alternative design working life. So if I change that to an agricultural building, now we have a slider. Now we can actually pick how many years we want to design this building for. So 24, 22, and as you can see that'll be just populated. So we'll just change it back to building structures. And a design working life has been of 50 years has been stipulated. Now, depending on the design working life and the type of structure that we've selected, that will also influence the variable actions. It will influence it'll influence the psi factors. All these different things influence what's to come next. Okay, so you just need to be very careful of that going forward. So we'll pick the type of structure. So building, road, bridge, footbridge, silo, tank, pipeline, tower, mast, chimney, etc. So leave it at building. Next we pick the altitude that this structure is built upon, so say 100 meters. So this will influence the type of wind load and snow load actions that will be influenced on that structure. Next we have to pick the consequence class of the structure. So again we have a table here, and this table is based upon the national annex that has previously been selected. So if we picked a different national annex, we will get a different type of table. So we can pick consequence class 2. From here we'll pick a reliability class, which the software has developed for us, which tells us it's a responsibility class 2 structure. And then from here we can get the target reliability index of the structure. So that's saying that we need to achieve a reliability index of 3.8 for this structure. Next, we determine the consequence class factor. So based on the consequence class, based on the national annex, the type of actions on the structure is saying that there's a factor of 1 that needs to be considered for all unfavourable actions. Okay. Next we pick the importance factor. So this doesn't really come into account for most buildings, but if you were to design a building subject to seismic activity, this would. Okay, so we'll pick a consequence class 2 for the seismic importance factor. If we were designing a bridge, for example, we would be able to make use of the supplementary model uncertainty factor. So we can select whether we want to include it or not. So the default is false. Next, we can consider whether we want to include any variable action reduction factor. So we can have none, we can have area, or we can have story. Okay, so you're only allowed to ever pick one out of the 3 possible options. So our default is none. Next, we can pick what type of actions we want to include in our generator. So I've split up all possible actions from the Eurocode into these various tables. Based upon what you select here will influence the type of actions that you can pick later down the road. So for example, I want permanent actions to be applicable to my structure. I want services to be applicable to my structure. I want imposed actions. I don't really need geotechnical, traffic, or construction, crane, machinery, environmental. I would like wind and snow. Do I want to consider accidental actions? Maybe, so we include that. And EHF actions. Okay. So next we get a list of all the actions that we've considered. Now we select how many directions that we want to consider for our structure. So let's just go 4. Okay, so if I selected 2, that would just give me 0 and 180. But because I want to get 4 different directions of my building, which would be 0, 90, 270 and 180, then I'll select 4. So I'll just make sure that all actions have been loaded successfully. That lets me proceed. And now here we can actually select all the actions from the action groups that we've selected up here. They all populate this table here. And from here we can select as many or as few as we want. So general actions, self-weight, yeah, we'll take that. Superimpose permanent actions, we'll include that one. Services, office, storage, maintenance. Let's go with wind. Let's go with snow, so snow case 1 and 2. Let's go with fire, and we'll include EHF at 0 and 90 degrees. Okay. So that tells us that the total number of load cases generated is 13. Okay. So I just want to see what those are. So that's our actions. So we can go back up and remove or add as we see fit, but we're happy enough with that. Next we include the story data. So if we wanted to see how many floors a particular load was applicable to, we can insert that here, but there's no real need at the minute, so just keep going. So now we have a permanent actions list, so that just gathers what permanent actions we've considered. it doesn't consider services as a permanent action. It considers them as a quasi-permanent action. And the thinking behind that is that services may or may not be there. So therefore, considering them may lead to an unconservative design, as well as not considering them may lead to an unconservative design. So it's important to consider both aspects of it. So for that reason, I've put them as a quasi-permanent action. So then it'll tell us then how many action groups we've considered and the actions within those action groups to our number. So for permanent actions we have 2 actions, services we have 1, etc. From here we can pick our design situations. So we go transient, persistent, accidental. From here we can pick the limit state, so we go ultimate and serviceability. So from these states that we've picked up here, we can actually go further in and pick which one we want to include. So let's go equilibrium, strength, and irreversible serviceability limit state, and reversible serviceability limit state. So if I didn't click serviceability limit state, these serviceability limit states here would not appear. Okay, so like I said, everything is based upon what you've selected before. So we can just select selected states, and that'll tell us what selected states we're going to be designing for. Okay, so every action group will have a status available to it. Okay, and what I mean by that, permanent action may be said to be stabilizing or destabilizing, or may not be even present at all. For variable action, it can be said to be leading, it can be said to be accompanying, or it could be said to be inferior or not present at all. So what I've done is I've considered all those different types of status, and I've given the option to be able to include or exclude certain status from being generated for those given action groups. Okay, so that sounds like a bit of a mouthful, but it's really not once you get into it. So for permanent actions, I want to remove the 0 status. So by removing the 0 status, that's basically saying that in every load combination generated, I want permanent actions to be present. Okay, so in terms of variable actions, I've assumed that inferior actions are stabilizing, and if there's no inferior in the status, it means that it's destabilizing. So QK lead, destabilizing, Q lead inferior, stabilizing, QK inferior, stabilizing, etc. Now, if we had picked the default national annex, so as in none, we would actually have more status that we can consider here in these options. But because we've selected Irish and we have selected building type, these are the type of status that is available to us to pick from. So I don't want any stabilizing actions for my live loads or variable actions, so we'll get rid of those and we'll leave that at that. Okay, so we'll just make sure that ran perfect. So I can see that they're populated there. 0 for permanent actions, and for imposed and environmental actions we can see those action status there as well. So we continue on and we consider whether an action is isolated or not. So what I mean by isolated or not means that basically if we have 4 actions within an action group, do I want only one of those actions to be present at any one time, or can they all be present, or a mixture of both? So if I pick permanent actions to be an isolated action, it means only one of those can occur at any one time and everything else is set to 0. So I don't really have a need for this at the minute. It's just a feature that's put in just in case I wanted to use it later on down the road. So we can just leave that as the default. Now, as the default, environmental and EHF and accidental actions are always going to be set to being isolated. So that means only one of those can occur at a time. Next, we have an option to consider favourable actions. Now you'll see here that permanent actions and services are the only ones that are available. If I didn't include the removal of the variable action favourable status, then that would appear here. Okay, so if I didn't pick these here for the imposed and the environmental, I would actually have the option down here to remove it from the options. Okay, so I want to ensure that I have favourable actions for permanent and services, so I'll just leave it as is. And as you'll see here, I can populate the action library and it's all populated there. Okay, so the next option that I need to pick in developing this generator is to consider whether actions occur simultaneously or not. So what I mean by that is, if I have 4 actions within an action group, must all of them occur at the same time to some degree or other? Or is it possible that only 2 occur and then the other 2 are set to 0? So if I select these 2 action types here, that means that there is no such thing as a combination which has 0 actions for that particular action group. So again, I don't really need to include them. They're set at blank for the default. So next I have an option to only consider actions that contain a leading action. So obviously in some cases there mightn't be a leading action that's developed in the generator. Do I want to still include it or not? So I have the option to only consider combinations that have a leading action. So I don't really need to include that. So my next option is to whether or not my next option is to consider whether or not actions occur independently or not. So what I mean by that is, the Eurocode states for the most part that variable actions should be considered as a single action. So a single action would mean that if I have a structure with office, storage and residential actions on that one building, that they all need to be leading or they all need to be accompanying. There's no such thing as in between or one or the other. And I've seen over the years that this mightn't always be the case. Sometimes if you consider everything to be leading or everything to be accompanying, that can often lead to unconservative results. So this cares for that. Okay, so I can have it so that in some combinations, some of the actions might be leading, some of them mightn't be present at all, some of them might be stabilizing, etc. So for the time being, we'll just untick both of those. And we have the option here to consider whether actions should be a single action or not. So I want my imposed actions to be a single action, but not environmental actions. And I want environmental then to be independent of each other. So that means if I have snow and wind acting together, that would mean that both snow and wind aren't leading, one or the other will be. Okay. So in the combination, if we have a leading action in our imposed actions, do we want to also consider a leading action in our environmental or whatever actions we have considered after that? So the default is false, okay, so we don't normally consider it, but the option is there if we wanted to change that. I'll just populate that library again. So this is the brains of the operation. This generates the permutations. Okay, so as you can see, it was lightning quick, and from that, that created 5,376 combinations. Okay, so that's 5,376 multiplied by, I think it was 13 actions. That was almost 70 values, sorry, 70,000 values that was generated there in less than a couple of seconds. So this is lightning quick. So if we wanted to view those permutations, so I don't want to view them all, we just view the first 20 set. And as you can see, this is it. Okay, now sometimes that can be very hard to distinguish what's what looking at it. So we can also view it graphically like that. Okay. So you can see where we have zeros, where we have leading actions. But generally I'll just leave it blank. So as we can see here, EHFs, they don't occur at the same time. That's good. You should be able to see here where maybe some of the actions are leading. No, it seems to be good so far. But anyways, you get the idea that this is what is generated so far, okay? But it's not filtered yet. It's just all the permutations are developed there, okay? But every type of building will have its own set of exclusions that have to be considered as well, okay? So for example, snow load, case 1 and case 2, they won't ever be acting at the same time, but they're generated here, and then the software will need to filter them out, okay? But again, that's no harm. And again, same with the wind. We've QK lead and QK accompanying over here. We don't want those to be acting together, but again, the software will filter them out afterwards, okay? This is just the basic bones of what was generated, okay? So we continue on. Now we pick our exclusive groups. So this allows the user to actually pick an exclusive group, any number of exclusive groups. So we can just select values here, add it to the list, and it'll consider those in generating exclusive groups. Okay, so what do I mean by exclusive groups? Well, say for example, I don't want to consider office actions and storage actions in the same combination ever. What I can do is I can add those to an exclusive group. The software will search for combinations with those two present. It will then it'll either give me the option then to have it so that none of these exist concurrently in a combination, or it will allow me to pick to keep one or the other. Okay, so I don't need to pick anything here at the minute because the software will already cater for the fact that wind loads shouldn't act together at the same time, snow loads shouldn't act together at the same time. There are a couple of other exclusions associated with the Eurocode as well that are also taken into account. Okay, So I can just run that. So here it gives me an option to include simultaneous exclusions. So the default is just false. Okay, so based upon my exclusions, now I need to apply those filters to the previously generated combinations. Okay, so I've now reduced the load combinations from 5,000 down to 2,400. Okay, so we can keep going. If I wanted to view that table, we can just so that's the new filtered table. Now, as you can see, these actions don't occur together. Some actions won't occur together as well. Okay. So that's what that filter process does. It takes a thinking out for the end user. Okay. So next we start needing to put numbers to these combinations, right? So we can select what type of analysis we're using on our structure. So first order linear elastic with without distribution, second order rigid plastic analysis, etc. So we'll just go first order linear elastic. Next, if we have an equilibrium limit state selected, we also have the option to check for the strength component of the members in that as well. So do we want to consider it yes or no? So we'll just go false. No. If there's pre-stress, do we want to include localized effects? So because we have no pre-stressed actions present, this is set to false. If we had pre-stressed actions present, this would give us an option to pick. Next we have a design working life factor. So according to the Dutch National Annex for the Eurocode, it actually allows for a reduction in the values of some of the live actions based upon the design working life. Okay, so we can choose to include that yes or no. Okay, so the default is false. It's not going to make any difference for us anyways for this time, because we've selected a 50-year design working life. So the only benefit to be gained is when you have a design working life less than 50 years. Okay, so next we can include a supplementary model uncertainty factor. So because we had selected previously up the top that we didn't want to consider it, that's automatically just set to 1. Okay, but if it was set that we did want to consider it, well then we have an option here to include it. Okay, and now we start populating that table with all of these possible values. Okay, so as you can see, that didn't really take a whole lot of time. So what we're after doing is we're after creating several different load combination tables for different limit states, for different design situations, set types, equations, and options. Okay, so what do I mean by that? Well, we're after creating all those combinations for the different ultimate and ultimate and serviceability limit states that we're after picking previously. So if I wanted to look at the table for the general 610 equation for ultimate limit state, I can pick equilibrium or strength, so go for strength. Next we can pick our design situation, so say persistent, set type B, equation 610, and we have no option here. Okay, so that's because equation 610 doesn't give you an option. If I had 610 A or B, now I have A or B here. Okay, so I'll just change that to the default, and we get our factored table. This is the factored table that needs to be considered for all combinations, for all actions. And best of all, it's filtered as well, so there's no duplicates here. So as you can see, it might be that obvious now, but there will be a couple of load combinations that will be omitted because they're duplicates. So for example, 59 and 61, it's not that you're missing combination 60, it's that combination 60 has already appeared. Okay, so like that I can change to serviceability. I want to get a reversible transient situation for that. Again, there's no set type. It was 14b, get values. Here we go. Okay, so that updates automatically depending on what I want. Okay, and then obviously I can just export that table and I'll get a table that's generated based on these values. Okay, so that's kind of the software that I've developed so far. There's other features that I want to include in it, but for the time being, this is the bootleg copy of it.